With respect to a fixed origin O, the lines L1 and L2 are given by the equations here and here, where lambda and mu are scalar parameters. Given that L1 and L2 meet, find the position vector of their point of intersection. Find the acute angle between L1 and L2, giving your answer in degrees to 1 decimal place. Given that the point A has position vector this, and that the point P lies on L1 such that AP is perpendicular to L1, find the exact coordinates of P. So that's the question, and I've got it here. So let's have a look at it. So first of all, the point of intersection. So here. Okay, so 9 plus lambda is equal to 2 plus 2 mu. And then 13 plus 4 lambda is equal to the j coordinate minus 1 plus mu. And then lastly, we've got minus 3 minus 2 lambda is equal to 1 plus mu. Okay, so right, so if we label these 1, 2 and 3, if we take 2 from 3, we'll be able to work out what lambda is because the mu's will cancel, won't they? So 2 minus 3 then gives, so on this side 13 minus minus 3 is 16, 4 lambda minus minus 2 is 6 lambda, minus 1 is minus 2, and these cancel, that's why we're doing it. So that tells us that 6 lambda is equal to, move the 16 over, minus 16 minus 2 is minus 18, so lambda is equal to minus 3. So there's the lambda value. So now we can work out the mu value. So by 3, we can use equation 3 or use equation 2. Let's use 2. Oops. By 2, because we've got a mu here and we can move this over. Mu is equal to 13 plus 1 is 14 plus 4 lambda. Lambda's minus 3, so it's 14 minus 4 3s are 12. 14 minus 12 is 2. So in other words, i.e. mu equals 2. Check 1. So let's check equation 1. 9 plus lambda is 9 plus lambda equals minus 3. And 2 plus 2 mu is equal to 2 plus 4 is 9 plus lambda. Oh, plus is 9 plus lambda is 6. I'll get it right in a minute. That's 6 there. And 2 plus 2 mu is 6. So the lines intersect because 1 is also satisfied. So lines intersect. And the coordinates, find the point of intersection at, well, let's put mu as 2 in. This is the x, y and z coordinate. 6 I, and then mu is 2, minus 1 is 1, so it's plus j, and then 2 plus 1 is 3, plus 3k. So there's where they intersect with the vector. So that's the point of intersection as a vector. So let's just look at the questions to see which format I wanted it in. Find the position vector. That's what we've done there then. That's okay. So now B, find the acute angle between L1 and L2 to 1 dp. So let's do that then. Here's a directional vector, so the lines intersect. 1, 4 minus 2. 1 plus 4j minus 2k. Dot product with the other directional vector. 1 plus 4 minus 2. 2, 1, 1. Dot product with 2, 1, 1. So this dot product with this vector will equal the product of the moduli using the dot product rule. 16 plus 1 plus 4. 16 plus 4 is 20, 21, so that's the square root of 21. And this one is 4, 5, 6, so that's the square root of 6 using Pythag. Times the cosine of the angle in between them, which we'll call theta. So cosine theta is equal to, now the dot product then, 2, 4 ones are 4, minus 2, over root 21 times root 6. There's a 3 in here, root 3 in here, and a root 3 in here. So we could take the 3 out, and it would be root 2 times root 7 is root 14. So it's, the 2's cancel here and here, 4 over 3 root 14. 4 over 3 root 14. So now we need to work out theta to 1 decimal place. Let's have a look here. Angle, the acute angle. Let's just go back to the paper to see what in degrees to 1 decimal place. So that's what we need to find then. So let's do that then. So we need to be in degrees mode, shift mode, number 3. And then we do shift cos 4 over 3 root 14. So shift inverse cos at 4 divided by bracket 3 times the square root of 14 outside the square root. Close that bracket, close the shift cos bracket, equals 69.1 degrees to 1 decimal place. So that's the angle then, the acute angle between them. So we've done that, and the point P, given that A is this, okay, and that the point P is on L1 such that AP is perpendicular to L1. So we've got 2 lines, we've got L1 and L2. This is 69.1 degrees. This is L1, this is L2, say. Now let's have a look at what we've got. It says given A is 416 minus 3 and the point P, so A is 416 minus 3, so A is here, and that's equal to OA is 4I plus 16J minus 3K is to here. Okay, good. We know where they intersect here, because we just worked out that point of intersection, haven't we? So we've done that in part A. 6 plus J plus 3K. 6I plus J plus 3K. That's that vector here. Okay, and we know the point P, and the point P is on L1 such that AP is perpendicular to L1. So P is on L1 such that AP is perpendicular to L1. So AP, which is a point on L1, so this is point P. P is equal to the coordinates wise. It's on L1, so L1, 9 plus lambda, 13 plus 4 lambda. So it's got 9 plus lambda, 13 plus 4 lambda. I'll just write coordinates here for the moment. 13 plus 4 lambda, and minus 3 minus 2 lambda. Minus 3 minus 2 lambda. So that's P, and we know AP is perpendicular to L1. So AP dot is perpendicular to L1. Now L1 has a direction. Sorry to go back up again, but it's 1, 4, minus 2. 1 plus 4 minus 2. I plus 4, J minus 2K. Now they're perpendicular, so the dot product says cos 90 is 0. So what have we got here? So we've got 9 plus lambda I plus 13 plus 4 lambda j plus minus 3 minus 2 lambda k. That's the, oh, AP, A to P, so 9 plus lambda minus 4 is 5. So that would be 5. And then 13 plus 4 lambda minus 16 is 4 lambda minus 3. So that would be minus 3 in there, wouldn't it? This is AP now. Minus 3. And then lastly, it's minus 3 minus 2 lambda minus 3 is plus 3, so it's just the minus 2 lambda there. So that would be the AP dot product with the I plus 4j minus 2k equals 0. So let's work that out then. 5 plus lambda times 1 is 5 plus lambda. And then minus 3 plus 4 lambda times 4 is minus 12 plus 16 lambda. And then minus 2 times minus 2 is plus 4 lambda equals 0. So we've got 16, 20, 21 lambda. So that's that one, and that one. 5 minus 12 is minus 7. Move it over to be plus 7. So that tells us lambda is a third. So lambda is a third in this problem. Go back up to the problem, find the exact coordinates of P. So here we go then. P coordinates. So let me just check that with the paper. Coordinates, yeah. P has coordinates. 9 plus lambda, 9 plus a third is 9 and a third. 13 plus 4 lambda is 13 and 4 thirds, which is 14 and a third. And the minus 3 minus 2 lambda is minus 3 minus 2 thirds. Minus 9 thirds, minus 2 thirds is minus 11 thirds. Minus 3 and 2 thirds. So that looks like the coordinates of P exactly.